Have you ever started a side project, like maybe something you were just tinkering with on a weekend to solve a really simple problem?
Oh, yeah. Usually with the best of intentions, right?
Right, exactly. And then you watch it, slowly grow over time until it just, well, it transforms into this completely unwieldy, unmanageable monster.
No, absolutely. It's so common.
It is a lot like planting a single innocent-looking tomato plant in the spring. You think, oh, this will be nice, a few tomatoes. And by late summer, you are staring at this overgrown, tangled vine that it's completely taken over your entire backyard.
Yeah, and you can't even find the actual tomatoes in there anymore.
Exactly. You're just fighting vines at that point. Well, welcome to today's deep dive, because that overgrown garden is exactly what a developer named Ang ran into.
And it's a great case study for us to look at.
It really is. Today, we are looking at Ang's recent dispatch. It's an entry dated July 25th, 2026, and it actually happens to be part 196 of their blog series, which is called Notes-on-Haskell-Programming.
That's a lot of notes.
Right. Part 196. So in this post, Ang realized their highly successful project had slowly mutated into one of those unmanageable monsters we were just talking about.
Yeah, the tomato vine situation.
Exactly.
Hmm.
So our mission for this deep dive with you today is to really explore the mechanics of how this programmer tackled a messy, overgrown code base. We want to see what this journey teaches us about, architectural organization and this core engineering concept called the single responsibility principle.
Yeah, the project in question here is called XS2 ebook, and the crucial context for you to understand right up front is that this project hasn't been failing.
No, not at all.
Right, it has actually been progressing exceptionally well. I mean, Eng notes that development has been going on for, quote, many moons.
Many moods.
Yeah, so a long time. But that sustained success, a constant iteration, adding new features, the minor tweaks applied over all those months, well, it carried a hidden structural cost.
It always does, doesn't it?
Always. Under the hood, the code base had just become deeply, deeply cluttered.
And, before you can fix a structural mess like that, you have to measure just how bad it actually is.
Right. You need a baseline.
Yeah. And Ang didn't just have this, vague feeling of disorganized code. There were very specific blinking red indicators that things had gotten completely out of hand.
Overly.
The first indicator was just the raw volume, like the lines of code had grown massive.
Which happens, yeah.
But the second indicator, and this is the one that's far more revealing about the architecture itself, was a staggering number of import statements stacked right at the very top of the file.
Right, and that second metric, that is the real diagnostic tool here.
Right.
Because in software development, an import statement is basically, it's your code declaring its dependencies.
Like it's raising its hand and saying what it needs.
Exactly. It is the file saying, in order to execute my specific functions, I need to pull in tools from this external library and that database driver over there and this other internal module. So if you open a file and you just see an absolute mountain of import statements before you even get to the core logic well, it reveals that this particular file is borrowing an enormous, sprawling variety of tools.
Okay, let's unpack this.
Yeah.
Because it's like opening a recipe, right?
Uh-huh.
Say you want to bake a really simple vanilla cake.
Sure.
You look at the recipe and you see a list of 500 ingredients at the top of the page. And it includes 3 different types of flour, a chainsaw, and a blowtorch.
But chainsaw for a vanilla cake.
Right. It's an immediate red flag that whatever you were about to make is incredibly complicated, and more importantly, that this specific recipe is trying to do way too much.
That analogy actually perfectly highlights the core issue of scope. Like, if your recipe requires a blowtorch and a delicate pastry brush, it is spanning entirely different domains of work.
Totally different worlds.
Yeah. And Ang found exactly that dynamic inside a core part of the XS2 ebook project. The primary culprit that was generating all this clutter, it was identified as a specific giant module called xs2ebook.testcli.
Right. And this single module was apparently doing, well, everything.
No, literally everything.
Ang writes that it was parsing the command line arguments, taking the raw text instructions from the user, but it didn't stop there.
No, of course not.
It was also reading the input files off the hard drive.
Mm-hmm.
It was validating those files to ensure the data was correct. It was orchestrating the entire execution pipeline of the whole application.
It's exhausting just listening to it.
And finally, after all of that, it was responsible for launching the generated document in a default viewer application.
Yeah, so Ang had inadvertently engineered what software architects call a monolithic module.
A monolith.
Right. If we visualize a theater production, right? This single piece of code was acting as the director calling the cues,
Oh, man.
the stagehand moving the props, the box office manager tearing the tickets, and the lead actor delivering the monologue.
All at the same time.
All concurrently, yeah.
Which just sounds completely unsustainable. Like if the stagehand trips over a wire, the lead actor forgets their lines
Right.
because they're literally the same person.
Precisely. From a systems architecture standpoint, that creates extreme brittleness.
Brittleness, yeah.
Because when a single part of a program handles everything, it forces every unrelated part of the program to become tangled together in the exact same execution context.
Oh, I see.
So if there is a minor bug in the logic that just reads a text file, it could easily crash the completely unrelated part of the program that handles opening the document viewer.
Because they're physically in the same space.
Exactly.
Yeah.
They share the same memory space, the same dependencies, and the same error handling pathways, purely because they are jammed into one giant file.
Okay, so the monster is clearly identified.
Hmm.
The xs2book.cli module is a monolith. It's doing the work of 5 different modules.
Right.
But, I mean, untangling a system that has grown together over many moons, that is incredibly daunting.
It's terrifying for a developer, seriously.
Hmm.
Interestingly, though, Aang didn't just stare at the screen trying to manually parse out all those dependencies. Aang actually sought an outside perspective.
Yeah, this is a really cool
They
program.
brought in an AI tool to analyze the code base.
The AI intervention is such a pivotal moment in this dispatch. Aang notes that the AI tool was the one that actually suggested the specific strategy to refactor this monolithic module.
Wow.
It analyzed the tangled mess, it identified the underlying architectural flaw, and it recommended enforcing the single responsibility principle.
The single responsibility principle, SRP.
Yep.
Okay, let me challenge the fundamental concept of this for a second. Because refactoring is a term that gets thrown around constantly in tech circles, and honestly, sometimes it feels like it's just used to justify busy work.
Sure, I can see that. So is refactoring a monolithic file just a fancy way of, I don't know, slicing a massive pie into smaller pieces, just so it visually looks like you have less on your plate? Because at the end of the day, all the code still has to execute. You are still dealing with the same total amount of logic, right?
That is a very fair pushback, because you're right, the total amount of logic doesn't magically disappear.
Right. The machine still has to do the work.
Exactly. However, we have to abandon the idea that this is just slicing a pie.
Okay.
What's fascinating here is that slicing a pie just gives you smaller, identical cross-sections of crust and filling, right?
It's the same stuff.
But the single responsibility principle isn't about making pieces smaller. It is about making them fundamentally distinct in their purpose. It dictates that a module should have one and only one reason to change.
One reason to change.
Yeah.
Okay, so instead of slicing a messy pie into smaller, messy slices, it is more like taking a chaotic kitchen where, everything is happening on one counter and separating it into a highly specialized assembly line.
Yes.
Like the mixing station only mixes, the oven only bakes. The logic is separated by function, not just arbitrarily chopped up to look smaller on the screen.
That is the exact mechanism of SRP. If your module is named xs2ebook.cli, and CLI means command line interface, right?
Right.
Then its singular reason to exist is to handle the command line options. It has absolutely no business reading files off a hard drive or validating data structures or launching external document viewers.
It needs to stay in its lane.
Exactly. When you apply the single responsibility principle, you are completely isolating the interface logic from the execution logic. You are essentially unmixing the dough.
Unmixing the dough. I love that. So let's look at how Aang actually pulled off this unmixing in practice. Let's move from the theory of SRP to the literal architectural changes inside the XS2 ebook project.
Because it was a major overhaul.
Huge. Aang completely revamped the structural layout.
Yeah, the before and after picture detailed in the post, it illustrates a deliberate, highly structured migration from chaos to order.
So starting at the very top of the program, there's this app/main.hs file, which is the main entry point where the software actually boots up.
Right. The front door.
Yeah, the front door. And it was completely cleaned out. Now it cleanly just imports a new module called xs2ebook.app.
And that's brilliant because it functions as a clean front door. When the compiler or a human developer enters the program, they are immediately directed to a central orchestrator.
Instead of a mess.
Right, rather than having to immediately navigate a maze of tangled initialization logic just to get the program running.
Okay, then we move down into the main source folder, this src folder, where that monster monolithic file CLI.hs was living.
Hmm.
Aang heavily modified it by violently stripping away all its extra jobs.
Just tearing them out.
Yeah. Now, it handles only the CLI options.
Yeah.
It parses the user's input, packages it up, and its job is entirely done.
And because CLI.h was stripped of all that execution and file handling logic, well, those processes had to go somewhere. They had to be relocated. So Aang birthed brand new, specialized files to take on those newly isolated responsibilities.
So app.h was created to handle the application pipeline and the orchestration. It's basically taking over that director of the play role we talked about earlier.
Exactly.
And then another brand new file, input.h, was created strictly for the I/O operations. So input.h alone handles reading the files, validating the incoming data, and managing the external viewer.
And what's great is all of these new, highly specialized files now sit cleanly alongside the existing well-behaved files that Aang already had established in the project.
Like which ones?
Oh, things like converter.h, lexicon.hs, parser.h, and tykes.hs.
Okay, wait, I have another skeptical question for you.
Bring it on.
If Aang is essentially just cutting code out of one master text document and pasting it into 3 separate text documents, doesn't that just mean they reorganize their digital filing cabinet?
I see where you're going with this.
Right, like how does mechanically moving text from one file to another actually improve how the machine runs the program? It really just sounds like putting the same exact papers into blue folders instead of red folders just for the sake of aesthetics.
It is such a common misconception that refactoring into separate files is just an aesthetic choice for the developer's reading pleasure.
It's not.
No, not at all.
Mhm.
By moving the code into distinct modules, Aang is mechanically and fundamentally decoupling the logic at the compiler level.
Mechanically decoupling. Okay, explain that.
So think about how a physical machine operates. If the gears that turn the wheels are literally welded to the gears that run the windshield wipers, the entire machine is incredibly brittle, right?
Yeah, that sounds like a terrible car.
It is, because if you want to swap out the wipers, you risk breaking the transmission.
Right.
In software, when file reading and CLI parsing are in the same module, they are essentially welded together. They share the same variable scopes, the same dependencies, and the same error states.
Ah, I see.
By moving them into separate files, the compiler literally treats them as independent entities. They can only communicate through strict, predefined data structures. You are fundamentally changing how the machine passes data around. You're entirely unwelding those gears.
Oh, wow. So you're building firewalls between the different functions.
Exactly. Firewalls.
If the file reader crashes, it crashes strictly inside input.h, and the fire doesn't spread to the CLI parser because they are structurally isolated from each other.
You nailed it.
Okay, that perfectly sets up the end of Aang's post, where they outline 3 massive payoffs that this new architecture directly unlocks.
And these payoffs, they are the ultimate validation of why developers spend days or even weeks enforcing the single responsibility principle.
It's worth the effort.
Totally. The rewards are immediate, and they fundamentally change the daily experience of working on the code.
So the first payoff Aang highlights is the separation of concerns. The command line parsing, the file I/O validations, and the execution logic are now completely decoupled.
Right. And this goes directly to reducing the psychological burden and the cognitive load on the programmer.
Which is huge.
It is. In the old monolithic setup, if there was a bug in how a file was validated, Aang would have to open a file containing thousands of lines of command line parsing logic, find the one block of validation code buried right in the middle, and just pray that changing it didn't break the CLI.
Sounds incredibly stressful.
It is. But now, if validation breaks, Aang simply opens input.h's. They are presented with a small, focused file that only deals with input. They can focus their entire mental energy on one isolated problem at a time.
And by isolating that logic, Aang inherently solved a massive headache for the rest of the program, which brings us to payoff number 2,
Yes.
improved testability and reusability.
Yes.
Aang mentions that other modules can now import specific functions without dragging along the entire massive CLI parsing dependency list.
And this connects right back to those 500 ingredients we talked about at the very beginning with the recipe analogy.
The chainsaw.
The chainsaw, right. In the old monolithic system, if a completely unrelated tiny part of the program just needed to use one small file validation function that was buried inside that massive CLI.hs file, well, it couldn't just extract that one function.
It had to take the whole thing.
Yes, it was forced to import the entire monolith. It had to bring all 500 ingredients, the blowtorch, the chainsaw, the CLI parser, the viewer logic, into its own workspace just to check if a text file was valid.
That is wild. It is dragging the entire stage production along just to borrow a single prop.
Exactly. But by splitting the logic into distinct modules, Aang achieved true reusability. Now, if another module needs file validation, it just imports input.hs. It gets exactly what it needs and absolutely nothing more.
Which is so much cleaner.
And furthermore, because these pieces are isolated, they're infinitely easier to write automated tests for.
Oh, right.
You can run rigorous, targeted tests on the file validation logic without having to simulate a user typing commands into the CLI. You can test the windshield wipers without having to turn on the engine.
The structural elegance of that is incredibly satisfying. And it plays directly into the third and final payoff, maintainability.
This is the big one.
Aang points out that smaller modules are much easier to reason about, sure, but they also highlight a very specific technical phenomenon. Aang notes that this new separated structure, quote, reduces compilation cascade.
Yeah, compilation cascade is the silent killer of developer productivity.
Okay, here's where it gets really interesting, because this concept is fascinating. Compilation cascade acts like the ultimate digital domino effect.
That's a great way to put it.
In a compiled language like Haskell, before you can run your program to see if a new feature works, the computer has to translate your human-readable code into machine language. It has to compile the entire project.
Right. And the compiler does this by building a massive dependency tree. It looks at all those import statements to figure out what files rely on what other files.
Right, checking the dependencies.
Right. Exactly. So if you have a monolith, a giant file like the old CLI.hs where every single other file in the program relies on it, it sits at the very base of that dependency tree.
Which means if you change one tiny line of code in that monolith, like let's say you just fix a typo in the help menu, text the computer registers that CLI.hs has changed.
Yep.
And because everything else is tangled up with it, the compiler knocks down all the dominoes and decides it has to recompile basically the entire program from scratch.
That is the cascade. And it can take minutes, and on larger enterprise projects, sometimes hours, just to compile and test a spelling correction.
Hours for a typo.
Oh, yeah. And the context switching alone destroys your focus. You make a tiny change, hit compile, and then you have to go get a coffee while the fan on your computer spins up.
That sounds miserable.
It is. But by applying the single responsibility principle, Aang completely isolated those domino chains.
Because CLI.hs now only handles CLI logic, right? So very few other files need to import it. So if you change a command line option now, the compiler looks at the tree and says, oh, only CLI.h changed, and nothing else depends on this specific logic.
And it recompiles that single file in milliseconds.
It doesn't have to rebuild the file validator or the lexer or the execution pipeline because they are mechanically decoupled.
Right. You are effectively pruning the dependency tree.
Yeah.
And these three benefits, the separation of concerns, reducing cognitive load, the isolated testability and reusability, and the elimination of the compilation cascade, they don't just exist in a vacuum.
They build on each other.
They absolutely compound on one another. Over the course of many moons, an architecture like this saves a programmer immense amounts of time, frustration, and mental energy. It ensures the code base remains a tool you control, rather than a monster you fear.
And successfully future-proof the garden so it can continue to grow without tangling itself into a knot.
Exactly.
So just to briefly recap this journey, Aang recognized that their highly successful XS2 book project was buckling under the weight of a cluttered monolithic module bursting at the seams with import statements and mixed responsibilities.
The 500 ingredients.
Right. And then, taking an AI's diagnostic advice to ruthlessly apply the single responsibility principle, Aang unmixed the logic. They created a sleek, modular architecture with highly specialized files like app.h and input.h.
Which was a game changer.
Yeah, this singular architectural shift unlocked immediate benefits for testing, reusing code, and maintaining the project without triggering that dreaded time-consuming domino effect of a compilation cascade.
It serves as a textbook example of a successful refactoring operation. But, the underlying philosophy here extends far beyond a Haskell programming language.
Oh, definitely.
Even if you don't know what a compiler is, there's a profound structural takeaway for all of us. The concept of a monolith isn't strictly a software problem.
No, it's everywhere.
It is a systems problem. And it exists heavily in human teams, in business operations, and even in our own personal workflows.
Well, we absolutely build human monoliths without even realizing it.
Right. Consider a growing startup or a project team. when one single person or one massive centralized spreadsheet is tasked with handling the initial client intake, the data validation, the daily execution of the work, and the final delivery.
You get the exact same clutter Aang experienced.
Exactly. You get the human equivalent of a compilation cascade. One small disruption in client intake completely ruins the execution team's entire week because everyone's workflows are tangled together.
They share the same memory space, basically.
Yes, separation of concerns is a universal life hack. When you ensure that your distinct tasks or your individual team members have a single, clear responsibility, you prevent burnout. And you prevent the human system from collapsing under its own intertwined weight.
We really do create these massive dependencies in our own lives, relying on a single routine or a single tool to do 500 different things.
We all do it.
Which actually brings me to a final thought I want to leave you with, building on the core of what Aang shared in this dispatch. We just saw how an AI tool was able to look at a complex software module, analyze its dependency graph, instantly identify that it was doing way too much, and suggest the single responsibility principle to untangle the whole architecture.
Yeah, the AI was able to see the structural flaws that the human developer had simply gotten used to living with over time.
Right, so here's something for you to mull over. If AI is now capable of diagnosing that kind of structural burnout and inefficient coupling inside a code base, well, how long before we use AI to analyze our own human job descriptions?
Oh, wow.
Or our daily routines? Just imagine feeding your weekly schedule, your emails, and your task list into an AI and having it map out your personal dependency graph.
That would be wild.
Imagine it telling you, you are operating as an inefficient monolithic module right now. You are trying to be the director, the stagehand, and the lead actor all at once, and it is causing a compilation cascade in your stress levels. It's time to decouple your logic.
Honestly, a structural analysis like that might reveal that a lot of us are well overdue for a personal refactoring.
I know my personal import statements are definitely out of control. I mean, I am pulling in far too many dependencies just to get through a Tuesday morning.
Same here.
But until that AI intervention arrives for our daily lives, we will just have to keep analyzing our own workflows, pulling the weeds and untangling the vines ourselves, ensuring we only have one reason to change at a time. Thank you so much for joining us on this deep dive. It has been an absolute pleasure exploring the architecture of a better system with you today. We will catch you next time.
Thank you for listening. Have a wonderful day.